Hello, Dr. Fawkes here. I've been asked quite a few related questions, and they're all to do with things floating on other things. For example, I've got ice in here. Why does ice float on water when it's made of the same material? Remember, ice is water. It's just solid water. So ice and water are the same thing. But the ice floats on top of the water. Before we come back to talk about the ice, let me give you another example. I've got some water here, and I've got some oil, and I've got an orange pit. First thing I'm going to do is put the oil on top of the water.
We can't use the terms heavier and lighter for this problem. The green bowl on the right, is clearly heavier than the blue bowl on the left, but that's because it's got more stuff in. We can't speak in those terms. We have to use the word density, and what we're talking about is if two things have the same volume, they're the same size, but one is heavier than the other, then we have to use the term density, and we say that one is denser than the other.
I'm going to drop this orange pip into the oil and water. See where it goes.
To understand density, you have to accept that everything's made of particles. Do you accept that? Good. Right. Something can be more dense than something else if it has bigger particles than something else. The other way something can be more dense is if it has the same size particles, but they are closer together, so there's more particles in a given space. I'm going to use bread to show you what I mean by particles being closer together.
Got some bread here. Pieces of bread are identical. Bread is low density. If I drop this piece on the water, it will float on the water. This piece I'm going to compress. All the particles of bread I'm going to push so that they are closer together. The amount of bread is the same. The weight is the same, the mass is the same, but the density is now greater. If I put this in the water, it should sink. The orange pip sunk through the oil because it's denser than oil, and the orange pip floated on the water because it's less dense than water. Maybe the particles are smaller, or maybe they aren't as close together. The ice floated on the water because it's less dense than the water, but because it's made of the same particles, we need to look at our special microscope picture again to understand that.
Here is a water particle. This is how we represent water, H2O. Okay, so look at the pattern on the shape of this. And now here is liquid water. So we've got lots and lots of these water particles, and they're all sloshing around each other. They're quite close together, and that's how we see a liquid. Now in a solid, the particles of water are arranged in a hexagon shape. Incidentally, that gives us a six-sided shape, which is why snowflakes have a six-sided pattern, as a snowflake in the picture here. So hopefully you can see that in ice, the particles of water are more spaced out, they're spread apart over a bigger area. So it is less dense, so ice will float on water. This brings us to our last question. Why do small things sink and big things float? By now you should be thinking this is to do with density, and you'll be right. If a small object has a higher density than water, it will sink. If a large object has a lower density than water, it will float. But it does look odd sometimes. This huge tanker, huge boat, is made of metal, which is denser than water. But if you look at the cross-section, you'll see that most of the inside of the boat is space, or air, which is very low density. So on average, the boat has a lower density than water. The boat will weigh less than the amount of water it takes the place of.
So I want you to use the word density when you're talking about different materials, something floating on something else. Look at this. This is a little cube. It measures 1 centimetre up, 1 centimetre across, 1 centimetre deep. It's a cubic centimetre. If this was made of water, it would weigh 1 gram. If it was made of oil or ice, it would weigh less than 1 gram. If it's made of metal, it would probably weigh more than 1 gram. So we can talk about how much something weighs per cubic centimetre, and that gives us density. They were brilliant questions, difficult to answer. I hope it made sense to you. Thank you as always for your questions. I look forward to hearing from you again. Bye.